Good day everyone. My name is Cyrus Zareno and today we will discuss about the SQL or Standard Query Language and the other types of database and big data analytics. So today I am delighted to present to you a concise overview of SQL or Standard Query Language. When we say SQL, it is a powerful programming language used for managing and manipulating relational databases. In this presentation, we will explore the fundamentals of SQL, its key components, and how it is used to retrieve and analyze data. Standard Query Language. SQL or Structured Query Language is a powerful tool that allows users to retrieve, modify, and analyze data stored in relational databases. So, the main objective of this SQL is to communicate with a database and to retrieve information from a database and to store and manage data. They provide a means of retrieving records or parts of records and performing various calculations before displaying the results. Next is overview of SQL and its significance in managing databases. SQL is a standard programming language that is used for managing and manipulating relational databases. Its significance is managing databases lies in its ability to perform operations such as data retrieval, insertion, update, and deletion. SQL allows for precise querying and filtering of data, enforces data integrity through constraints, facilitates transaction management, ensures security and access control, optimizes database performance, and provides a standardized approach to database management across different systems. Here are the benefits of using SQL for data manipulation. First is simplicity and readability. SQL uses a simple and intuitive syntax that is easy to learn and understand. Its declarative nature allows users to specify what data they want to retrieve or manipulate, rather than how to do it. This makes SQL statements highly readable and reduces the complexity of data manipulation tasks. Second is standardization. SQL is a standardized language, meaning it has consistent syntax and functionality across different database management systems. So this allows for portability and ease of migration between systems, making it convenient to work with databases on different platforms. Next is efficient data retrieval. SQL provides powerful querying capabilities, enabling users to retrieve specific data from databases efficiently. Next is data manipulation operation. SQL provides a set of statements. There are three statements of SQL: the insert, update, and delete. For manipulating data in databases, these operations allow users to add new records, modify existing data, and delete unwanted information, enabling efficient data management. Next is transaction management. SQL supports transactional operations, allowing users to group multiple database operations into a single unit. Next is scalability and performance. SQL enables indexing, query optimization, and performance tuning techniques to enhance database scalability and performance. Indexing allows for faster data retrieval, while query optimization techniques ensure efficient execution of SQL queries and improving overall performance. Lastly, we have security and access control. SQL offers features for managing security and access control to databases. Users can define user rules, assign privilege, and control access for data, ensuring that only authorized individuals can view, modify, or manipulate the data in the database. Overall, using SQL for data manipulation provides a standardized, efficient, and powerful approach for managing databases. Its simplicity, flexibility and support for data integrity, transactions, security, and performance optimization. Make it a valuable tool for working with relational databases. Next is SQL syntax. SQL syntax is the set of rules that govern how SQL statements are written and executed. The syntax includes rules for formatting, punctuation, keywords, and operators. It's important to follow these rules carefully because even small mistakes can cause errors or unexpected results. In SQL, we have four statements. First is select, insert, update, and delete statements. First is select. Select statement is SQL used for retrieve data from database. It allows user to specify which columns to retrieve and which table or tables to retrieve data from. Second is insert statement. It is used to add new records or data into a table in a database. It allows users to specify the table name and the value to be inserted into corresponding columns. Next is update statement. Update statement is a SQL used to modify existing records or data in table within a database. It allows users to specify the table name and columns to be updated. Next is the delete statement. In SQL, it is used to remove one or more records from a table within a database. It allows users to specify the table name and the conditions that determine which rows should be deleted. So in performing the SQL statement, not only the select but the for statement, they have a syntax rules to be followed to avoid errors or unexpected result. So later on, it will be discussed in the next reporter on how the SQL statements perform.
Good morning, everyone. My name is Kinter Bisoga, and here I am going to report my part is retrieving data with select. The select statement is one of the most commonly used statements in SQL. It allows you to retrieve data from one or more tables based on specified criteria. The syntax of select statement is quite simple, but it can be very powerful when used correctly. To retrieve data using the select statement in SQL, you need to specify the columns you want to retrieve and the table from which you want to retrieve the data. So here is an example of the retrieving data with select. Retrieving all the columns from a table and select from the table name. But first, wait lang. But first, we want to know what is select, from, and where. Select is specified the columns or expression you want to retrieve from database. From, it indicates the tables or from which you want to retrieve the data. As you can see here, there's a from in here. And where is an optional clause that allows you to specify condition to filter the rows based on certain criteria. Only the rows meet the specified condition will be included in the results set. So here you can see here, retrieve specific columns from the table. So manong gingon ako ganina nga select is specifies the columns or expression you want to retrieve the data, and the where is like this: select column 1, column 2 from table name where the condition. Here is modifying data: insert, update, and delete. So it's obviously this insert is like you want to add new data or the table. That's why it's called insert. And there's a syntax of insert. Insert into table name values, value 1, value 2, and value 3. Here are the examples of insert. Insert into employees values I, John Doe, sells 50,000. So here you can add names and the sales. And update is, and next is the update. Update is used to modify existing data. Just like you want to update, update syntax. Update table's name set column equals new underscore value where conditions. Here are examples of update. Update employees set salary equals to 55,000 where employee underscore ID is equals to 1. And then delete is used to remove from the table. So it's like removing the data from a specific table. Syntax table from table name. Here is the example of delete. Delete from employees. So move on to the next part is working with multiple tables. Tables joins in SQL refer to the process of combining rows from multiple tables based on related columns between them. It allows you to retrieve data from multiple tables simultaneously by specifying the relationship between them. The join operation matches rows from one table with rows from another table based on a common columns or columns. There are several types of joins in SQL that allow you to combine data from multiple tables based on common columns. Here are the most common types of join: the inner join and the left join. The inner join returns only the rows that have matching values in both tables being joined. So have the same value. It selects records where the join condition satisfied in both tables. Here is the select one. Here's the syntax: the select one and column 2 from table 1. So here the inner join table 2 on table 1 equals to table 2 that column. And the left join returns all rows from the left table, obviously the left, and the match rows from the right table. If there is no match, it returns null values for the right table column, right table columns. Here the syntax: select column 1 and column 2 from table 1. Left join table 2 on table 1 column equals table 2 dot column. And the next is here the other common types of join: right join, full join, and cross join. Right join is the opposite of the left joins. It returns all rows from the right table and the match rows from the left table. If there is no match, it returns null values for the table's columns. So here the syntax: select column 1, column 2 from table 1, right join on table 2. Table 1 that column equals table 2 that column. So it's like the opposite of the left. Here is the full join. Full join returns all from both tables and combines the result of the left join and the right joins. If there is no match, it returns null values for the unmatched column. So it's like the right and the left combined. Here's the syntax of full join. Select column 2 from table 1, then full join table 2 on table 1 that column equals table 2 that column. Cross join here this, and the last is the cross join. The cross join returns the Cartesian product of the two tables, which means it combines every row from the first table with every row from the second table. It does not require join condition. It's like a separate from the other table, separating the other column and the also other column.
Next is data integrity and constraints. Data integrity refers to the accuracy, consistency, and reliability of data stored in a database. It ensures that the data is correct, complete, and reliable throughout its life cycle. Constraints are rules that govern the type of format of data that can be entered into a database. They help ensure data consistency and accuracy by preventing the insertion of incorrect or invalid data. So the difference between data integrity and constraints is the data integrity is the assurance of the accuracy and consistency of data over its entire life cycle, while the constraints are used to specify rules of the data in a table. Constraints are used to limit the type of data that can go into a table or ensures the accuracy and reliability of the data in the table. Next is some common types of constraints. First is primary key uniquely identify its row in a table. So a primary key is a column or a combination of a columns in a table that uniquely identifies each row in that table. So it enforces uniqueness and provides a way to uniquely identify records. The primary key constraints that ensure primary key values are unique and not a null. Next is foreign key establish relationships between tables based on matching values. So a foreign key is a column or a combination of columns in a table that establish in a link or a relationship between two tables. It represents a relationship between the data into the two tables based on the matching columns or columns. The foreign key constraints ensure referential integrity, meaning so that the values in the foreign key columns must exist in the reference table's primary key column. So the next is unique constraints enforce uniqueness across column in a table. So a unique constraint ensures that the value in a column or a combination of columns are unique across all the rows in a table. So unlike the primary key constraint, a unique constraint allows null values, but if a column with a unique constraint has a non-null value, it must be unique and it prevents duplicate values from being inserted into the specific columns. So next is the not null constraints ensure that a column cannot contain null values. So the last one is the not null constraints ensure that a column cannot contain null values. So a not null constraints ensure that a column in a table cannot contain null values. It enforces the requirement that the column must have a value for every row. By applying a not null constraint, you ensure that a column will always contain meaningful data and prevent the insertion of null values. The constraints are important for maintaining the integrity, enforcing relationships, and preventing inconsistencies or invalid data in our database. They help to ensure that the accuracy, reliability, and consistency of data stored within the table.
There are other types of database. Number one is the object-oriented database. Object-oriented databases store data in the form of objects which encapsulate both data and methods or operations that can be performed on the data. This type of database is well suited for object-oriented program languages. The example of this is the MongoDB and Apache Cassandra. So the Mongo database is an open source NoSQL database management system. Uh, It is non-relation document that provides support for JSON-like storage. It is flexible model that enables you to store unstructured data. This type of database make it fast and easy to build generative AI powered application. The Apache Cassandra is a free and open source distributed and decentralized storage system that designed to handle large amount of data across the world. Uh, it also provides high availability uh, with no single point of failure, and it is also scalable and consistent. Next is the hierarchical database. Hierarchical database organize data in a tree-like structure which is where which record has a parent-child relationship with other records. This type of database is primarily used in legacy systems. The example of this is the IMS or the Information Management System. Uh, an information management system is a computer system or set of computer programs. It is used to track and store information, and it plays important role in daily activities of almost any businesses. This system handle various data that business businesses use to inform decision making, which can lead to their stability. Because of this, businesses will dedicate numerous resources to information management system. An appreciation of the system can help you better understand how they can be used to improve various workplace operations. The third one is the network database. Network databases are similar to hierarchical databases, but they allow for more complex relationships between records. Records is in a network database can have multiple parent and child records forming a network-like structure. This type of database is also used in legacy systems. The example of this is the integrated data store. The uh, the integrated data store is a storehouse that resides directly on a device. It was an early network database management system that largely used by industry and known for its high performance. It was developed at General Electric in the early 1960s. The fourth one is the NoSQL database. NoSQL database or not only SQL databases are designed to handle unstructured, semi-structured, and big data. They provide flexible schemas and horizontal scalability. NoSQL database can be further categorized into key value stores, document stores, columnar databases, and graph databases. The difference between SQL and NoSQL is that SQL databases follow a structured relational data model with predefined schemas, while NoSQL databases provide a more flexible and scalable approach to handling unstructured or semi-structured data without predefined schemas. Next example is the in-memory database. In-memory databases store data primarily in the main memory, which is the RAM of a computer, rather than on disk. This enables faster data access and processing compared to traditional disk-based databases. So it means that each time you query a database or update data in database, you only access the main memory. So there's no disk involved into these operations, which is good because the main memory is way faster than any disk. The example of this is the Memcache and Apache Ignite. Um, Memcache, which is kanang distributed memory caching system that often used to speed up dynamic websites by caching data and objects in RAM to reduce the number of times an external data source such as database or API. Apache Ignite is that that is durable, strongly consistent, and highly available with powerful SQL key value and processing APIs. One of the main use cases for Apache Ignite is the in-memory database, which scale horizontally and provides ACID transactions. The time series database. Time series databases are optimized for handling timestamp or time series data such as sensor data, logs, or financial data. They provide efficient storage and retrieval of database on time intervals or specific timestamps. So time series database are simply measurement or events that track, monitored, sampled, and aggregated. It allows one to see what factors influence certain variables from period to period. It can be useful to see how a given asset security or economic variables changes over time. One of the popular example of time series database is the InfluxDB and Prometheus. So the InfluxDB is a push-based system that requires an application to actively push data into database. It is used for storage and retrieval of time series data in fields. The Prometheus is a pull-based system that provides monitoring and alerting functionality for cloud native environments, including Kubernetes. Spital database. Spital databases are designed to store and query spatial or geographic data. Spital. They have specialized data structures and indexing techniques to support spital data types such as points, lines, and polygons. Uh, Spital database is usually a relational database that has been enhanced to include spital data that represents objects defined in a geometric space, along with tools for querying and analyzing such data. The example of this is the PostGIS, Oracle Spital, and Microsoft SQL Server with Spital extensions. The last one is the cloud database. Cloud databases are hosted and managed on cloud platforms. They offer scalability, high availability, and ease of deployment. Example of this includes Amazon Web Service, databases like Amazon RDS and Amazon DynamoDB, Google Cloud SQL, and Microsoft Azure Cosmos Database. So, data cloud database is kanang employed, delivered, and accessed in a cloud. It organized and stores unstructured, and semi-structured data like traditional on-premises databases. These are just a few examples of various types of databases available. Each type has its own strength, weaknesses, and use cases. The choice of database depends on the specific requirements of the application or system being developed.
Good day everyone, I am Angelica Doria and I am here to present a topic that is highly relevant in today's modern age. So, I want you for just a second imagine a world where massive amounts of data are being generated. So from social media interactions and online transactions, it is highly evident that we are living in the era of big data. So today, I will present to you the big data analytics and its transformative power in unlocking the hidden insights within this vast ocean of information. But amidst the sea of data lies a challenge. Now, how do we navigate through the wealth of information and transform it into valuable insights? That's where big data analytics comes into play. It's a discipline that enables us to extract meaning from it, identify patterns, uncover trends, and derive actionable insights that can revolutionize the way organizations operate and make decisions. So that's a quick overview for the big data analytics. Let's proceed to data sources. So big data comes from various sources such as social media platforms, sensors, online transactions, mobile devices, and more. Increased use of digital technologies like these has led to a massive increase in data generation. And that's why we experience data explosion. We witness and we experience data explosion because of the increased connectivity, content creation, e-commerce, and machine-generated data. Okay, moving on to the 3 V's of big data. So we have the first V, which is volume, the second V, velocity, and the third V is variety. Now, big data is characterized by its high volume, which means large amount of data, high velocity, which means fast generation and processing speed, and high variety, which means diverse data types and sources. Okay, so I wanted to discuss these 3 V's and what the purpose of it in the context of big data. So volume. To define, it refers to the sheer scale and size of data generated and collected. Big data involves dealing with massive amounts of data that surpass the capabilities of traditional data processing methods. Okay, so we have the purpose of velocity in big data. So its purpose is to volume in big data. So the purpose of volume in big data is to provide a rich and extensive data set that allows for comprehensive analysis, accurate predictions, uncovering hidden patterns, and supporting data-driven decision-making process. Okay, so for the second V of the three V's of big data, we have the variety. So variety signifies the diverse nature of data types and sources. Big data encompasses structured data. Examples would include databases, and for the unstructured data, examples would be social media posts. Then we have semi-structured data. Examples would include XML files and more. Now, it involves integrating and analyzing data from various sources. So that's the keyword for this second V, the variety. So variety would equate to various sources with different formats and structures. Okay. So what is the purpose of variety in big data? So variety in big data ensure a comprehensive understanding of the subject matter by incorporating diverse data sources. This leads to more informed decision-making, the ability to analyze unstructured data, innovation and discovery, and customized analytics approaches. Now for the third V of the three V's of big data, we have velocity. So velocity represents the speed at which data is generated, processed, and analyzed. Big data is characterized by real-time or near real-time data streams that require efficient processing to extract insights in a timely manner. Okay, what is the purpose of velocity in big data? So the purpose of it is to support real-time or near real-time processing. So this would result into an improved operational efficiency, which would deliver personalized experience, leverage predictive analytics, and harness the potential of IoT applications. So there are of course similarities and differences between these three V's. So those are volume, velocity, and variety, as we have previously mentioned. Now, volume, velocity, and variety represent distinct aspects of data. So for volume, it emphasizes the scale or size of data, while velocity emphasizes the speed of data flow, and variety emphasizes the diversity of data types and sources. But together, these characteristics highlight the unique challenges and opportunities associated with managing and analyzing big data. Now for the next slide, which is the importance of big data analytics. So big data analytics enables organizations to extract valuable insights, make data-driven decisions, identify patterns, and gain a competitive advantage. It is very relevant in various industries such as business, healthcare, finance, research, and government. It is important for business, for it allows them to gauge their customer behavior, to understand the market trends, and for the overall operational efficiency of the business. Now, for the healthcare, it is beneficial because it analyzes large-scale health records, medical imaging data, and genomic data. Healthcare professionals can gain insights into disease patterns, personalize treatments. They could then detect outbreaks and enhance public health interventions. For the finance, it is important for the risk analysis, for fraud detection, and algorithmic trading, which means to automatically execute trades in financial markets. For the research, it is important in the areas of genomics, astronomy, climate science, social sciences, and more. For the government, the importance of big data is that they could leverage data from multiple sources to improve public services. Now, overall, big data analytics is essential or important for organizations as it empowers them to make informed decisions, understand their customers, optimize business processes, manage risks, drive innovation, leverage predictive insights, and achieve continuous improvement. It has become a strategic imperative in today's data-driven world, enabling organizations to unlock the full potential of their data and gain a competitive edge. Now, data storage and clusters. So big data usually works in a cluster. This is because the clustering key approach in handling big data is scalable, parallel, it has parallel processing capabilities, and it is flexible. So these characteristics enable efficient and effective processing of large volumes of data. It then empowers organizations to extract valuable insights and make data-driven decisions. Now, storage systems are attached to a cluster of nodes. And nodes are individual machines or servers that work together as a team to process and store large amounts of data. Each node performs tasks like data processing and storage. Cluster nodes enable faster processing, parallel computing, and scalability, and of course data querying. Now, there are different kinds of nodes. So we have commodity servers. So these are standard off-the-shelf servers that provide a cost-effective solution for building a cluster. So we also have virtual machines, which are software-based representations of physical computers. We now also have high-performance computing, or HP nodes. So HP nodes are specifically designed for high-performance computing tasks. They typically feature powerful processors, large amounts of memory, and fast interconnectivity for efficient data processing and communication in clusters. We also have cloud instances, so cloud computing platforms like Amazon Web Services, which is AWS, Microsoft Azure, and Google Cloud Platform, GCP. It offers virtual instances that can serve as cluster nodes. So these examples represent different types of cluster nodes that can be used in big data environments. The choice of cluster nodes depends on factors like computational requirements, data processing needs, cost considerations. We also have scalability. It is a major factors for the cluster nodes picking. And then the specific technology preferences. Okay, data visualization. So complex data can be visualized in an visually appealing and understandable format, such as charts, graphs, and dashboards. These will help communicate insights and patterns effectively. So, data visualization is crucial in big data as it simplifies complex data. So, by using the data visualization, it could actually simplify complex data that is the big data. It could communicate insights effectively. It helps identify patterns and trends, supports data-driven decision making, enables exploratory analysis, enhances data storytelling, and facilitates collaboration and knowledge sharing. So overall, it is a powerful tool for extracting meaningful insights from big data and driving informed decision-making processes. Okay, for the machine learning. Machine learning is a subset of AI that involves the development of algorithms and models that automatically learn from and make predictions or decisions based on large data sets. Okay. Here are some examples of machine learning applications across different domains. So we have email spam filtering. So machine learning models can be trained to classify emails as spam or legitimate based on patterns and characteristics in the email content, headers, and metadata. Credit scoring. Machine learning algorithms analyze credit history, financial data, and customer profiles to predict creditworthiness and assess the risk of lending to individuals or businesses. Now, by using the machine learning, we have virtual personal assistants. So virtual assistants like Siri, Google Assistant, and Alexa, they utilize machine learning to understand and respond to user commands. They provide personalized recommendations, reminders, information, and a lot more. And the medical diagnosis, they also use machine learning algorithms. It could assist them in diagnosing medical conditions based on patient symptoms, medical history, and diagnostic test results. For example, machine learning models have been developed for diagnosing diseases like cancer, diabetes, and heart conditions. So in fraud detection, we also have machine learning algorithms in there. Fraud detection in banking. So it analyzes transactional data to detect patterns or fraudulent activities, enabling banks and financial institutions to identify and prevent fraudulent transactions in real time. We now also have autonomous robots. So machine learning algorithms are used to train robots to perform tasks autonomously, such as object recognition, navigation, and manipulation in environments like warehouses, manufacturing, and healthcare settings. Now we also have sentiment analysis. So machine learning techniques can be employed to analyze and classify sentiment expressed in textual data, such as social media posts, customer reviews, or survey responses. This enables businesses to gain insights into public opinion and customer satisfaction. We also have energy load forecasting. So there are machine learning models now that analyze historical energy consumption data, weather patterns, and other factors to forecast energy demand, aiding in efficient energy resource planning and optimization. And Last example would be the recommendation systems. Machine learning algorithms power recommendation engines used by platforms like Netflix, Amazon, and YouTube to suggest personalized content, products, and services, based of course on the user preferences and behavior. So these examples demonstrate the broad range of applications where machine learning techniques are being leveraged to extracted insights to automate processes and make accurate predictions in various industries. I have reached the end of my presentation, and as a conclusion or a recap, big data analytics is a transformative technology that unlocks valuable insights from vast amounts of data. It enables businesses to make smart decisions and gain a competitive edge. To leverage the full potential of big data analytics, we must embrace its opportunities. We have delved into the fascinating world of big data analytics and explored its immense potential. Let us move forward together, driven by data, innovation, and a shared vision for a future powered by insights. That will conclude my presentation. Thank you so much for listening.